Hey guys, welcome back. In this particular video, we're going to take a look at the ACL on the firewall and the importance and the effect of the ACL on a ASA firewall. In this particular video, the main things that we'll be discussing is first we'll review the default traffic flow, how traffic flows through an ASA firewall. We'll take a look at the firewall ACL. We'll take a look at the configuration command, which is a little different than the ACL on a router, and then at the end, lab configuration. So to get started, let's go ahead and take a look at the default traffic flow through an ASA firewall. Now, to do that, again, this should be a recap for you guys. We've been talking about it all along. Let's say I have an ASA firewall over here. On the ASA firewall, each interface gets a security level assigned to it. Let's say this is my inside interface connecting towards my corporate network. It would have a security level set to 100. Let's say this is my outside connected to the internet. It would have a security level set to 0, and maybe this is a connection to two different companies that are connecting in, like a partner network that's connecting in through an MPLS network or some type of VPN to connect in and maybe access my DMZ network. And this is another VPN that's coming in. So these two I've set it to 50. So how does the traffic flow go through the firewall by default? As we have talked about earlier on in the earlier videos, traffic from a high security level interface towards a low security level interface, by default, all traffic is allowed. Not only all traffic is allowed, TCP and UDP traffic is inspected. So the return traffic is put into the state table, also known as the connection table. And the return traffic is also allowed to come back. Traffic coming from low to high. So let's say somebody wants to initiate traffic from the outside network, the internet, towards maybe your DMZ. Maybe this is not your partner network. Maybe it is your DMZ network. I have a web server down here. I want traffic from the outside to come in into my web server. That traffic by default is going to be blocked. So that traffic, which is traffic coming in from a low security interface to a high security interface, that flow is blocked by default. And if you do want to allow that traffic, either you have an entry in the connection table, which is return traffic, or you need to create an explicit ACL and apply it to the interface. You would apply an ACL to the outside interface for inbound traffic into the outside interface, allowing whatever traffic you want to allow from the outside interface towards the higher interfaces. That's an explicit ACL that you can create. But the thing that you need to understand about the ACL, the function of the ACL is to govern traffic that is going through the firewall. So for example, if it's coming from the outside and is destined to this particular server over here, that means the traffic came in from here into the interface, into the firewall, and exited the firewall. So it was traversing through the firewall. It was not meant to the firewall. It was not destined to the firewall. So that is called through traffic. And that through traffic can be allowed by using or controlled by using an explicit ACL. So if traffic is coming from the outside and going towards the DMZ interface or the inside interface, you write an ACL to allow the traffic. The effect of the ACL, the premise of the ACL is to allow traffic that is going through the firewall. What the ACL does not control is traffic that is destined to the firewall. So if somebody is trying to ping the outside interface, so for example, let's say somebody's sitting on the outside and he's trying to ping or telnet into this interface where the IP address is the outside IP address of the firewall, that traffic is not controlled by an ACL. Even if you put in permit IP any, that does not, or deny IP any, that does not control traffic that is destined to the firewall. That is done by services, which we'll discuss in the next video. At this point, my focus is going to be to control through traffic. But again, as I said, I want you to understand whatever I do in this particular video is always going to govern or control traffic that is going through the firewall, not to the firewall. So it's coming from, let's say, the outside, the internet, and it's going towards your DMZ servers. That is the traffic that I can control with the ACL. I cannot control traffic that is going to the firewall with the ACL. I'll show you how to control that as well. And by default, there's a lot of controls that are in place on the ASA firewall by default, so you don't need to worry about it. But if you do want to control it, or if you want to allow some traffic coming in, I'll show you how to do that as well in the next video. Here, our focus is the ACL. So what we've taken a look at this point is the default traffic flow, high to low and low to high. So again, it's the same thing that we discussed in the earlier video, so there's nothing new over here. I just need to fix this. Over here, inspection. What is this? This should be good. So by default, all traffic is allowed from high to low as long as the routing information is in place. So obviously your routing has to be in place for it to be allowed to go out. All traffic is allowed to flow from high to low. Only TCP and UDP traffic is inspected. So if I try to do an ICMP, it'll be allowed to go out, but it won't return because there's no connection in the connection entry. So that is required. The stateful inspection is required, and that's only done by default for TCP and UDP. This should be review information for you from the previous videos. Low to high blocked, and if you want to allow traffic coming in from the low to high, either it should be in the connection table, or you can create an explicit entry, that is by controlling it using an ACL. All right, so when the packet comes in, it checks the connection table first. If it's not there, it checks the ACL, permits it. If it's not there, it'll block the traffic, the default action, low to high. The other thing that we also discussed earlier on was the same security interface. That's what I was trying to explain to you guys. If you are in a situation where you have two partner networks coming into your network and you don't want them to talk to each other. So if I have a firewall over here, I have a VPN connecting in from partner 1. So that they can access my DMZ servers over here. DMZ for my partners. And I have another partner over here that is also coming in through a VPN. This is partner 2. And I don't want traffic to go between the two interfaces. I set the security level to both, set to 50. If I do that, even an ACL over here will not help these two partners talking to each other. Even if I put an interface ACL saying permit IP any, if the interface levels are the same, it's an explicit block for the traffic. They will both be able to come into my, let's say my DMZ, which is 75. I still need to put an ACL to allow it to come in, but at least an ACL will allow them to come into my DMZ for partners, but they will not be able to talk to each other. Now there are instances where you also use this for the complete opposite thing. So this is one implementation of it. This is the default implementation. If you have two interfaces with the same security level, they will not be able to talk to each other. Now, the other thing that you also need to understand is sometimes what happens in an environment, you might have two interfaces or three interfaces that belong to the same department. So maybe 3 different VLANs, 3 different subnets, sales 1, sales 2, and sales 3. Besides having the outside, besides having the DMZ. And maybe this is your marketing network. So one of the things that you can also do is you can set the security level to 50 over here, the same level, and the other ones will have your normal outside would be 0. Let's put this as 25 so that sales can go to the DMZ. It's higher than that. And marketing, let's put it as 60, just as an example. So these 350s, I don't want any firewalling done between them. I want them to talk to each other normally. So one of the things that I can also do is use this command called the same security traffic command. It's a global command which allows you the ability to say, hey, listen, if there's multiple security interfaces or multiple interfaces with the same security level, allow the traffic to go through without any firewalling between two different interfaces. if there's the same security level, I don't want the high load to come into effect. I want them to talk to each other. But the thing is, you cannot have in that case, you would not be able to do, let's say, partner one and partner two, because this is a global command. You either do one or the other. So if I had that partner one, partner two example over here, let's say I put that as 20 and 20. Now once I do that, they will not be able to, so that control that I had in the previous example would not be there. They would also be able to talk to each other without using an ACL. I do have the ability to put an ACL to control them then, but by default, when you put this command in, they will be able to talk to each other without any ACL. So it's two extremes. You either allow all traffic or you allow no traffic. Okay. Now, again, even if you allow all traffic, you do have the ability to use an ACL to control it. So that's this part over here that I'm explaining over here with the same security level. And the interface I put in over there as well. If you use the above command, it allows all traffic between two interfaces with the same security level. You do have the ability to use an ACL to control it if you want to. All right. With that in mind, let's get to the next subject, the main subject of this particular video, which is the ASA firewall ACL. As I said, and I've been harping about this all along, is that the ACL on the firewall only controls what? Traffic that is through the firewall. It does not affect any traffic destined to the firewall. So if I write an ACL deny ICMP any on the outside, it is not going to block people from pinging the outside interface. It is going to affect traffic going through the ASA, but not to the ASA. All right. So that's something that you need to be aware of. Now, other characteristics of an ACL, firewall ACLs are extended ACLs by default. So when you type in the command access-list, which is the syntax for a firewall ACL, you put a name or a number, doesn't matter. It's treated as a name. So let's say ABC or 101, it doesn't matter. It'll be treated as a name for the ACL, not a number. No standard extended ACL numbers that we have on the router ACLs. So it is going to be treated as a name even if you put ACL 101. Or for that matter, even if, if I put ACL 1, it is still going to be treated as a named ACL. ACLs are always by default extended ACLs. So not a standard ACL. So don't get fooled by ACL1 being a standard ACL if you're coming from the router background. Access-list 1 is treated as a name. It is an extended ACL. That's what I'm trying to explain to you guys over here. All right, those are the two differences over here. The last difference, a very important difference, is that it does not use the wildcard mask. In the wildcard mask on a router, if I wanted to match any bit, it would be a 0. So for example, if I wanted to block or deny IP, any traffic coming in from a particular network, let's say 192.1.20.0, on a router, my mask would be the inverse mask or the wildcard mask. So the mask over here would have been 0.0.0.255, where 0 is an indication that you want to match it, and 1 is an indicator I don't really care what the host address is. I want to match the first 3 octets. Permit IP any, and you can specify, let's say, a host over here, just like you do, let's say, 10.5 as an example. So I'm blocking any traffic coming from the 20 network to that host. Now on the firewall, it is not an inverse mask. It's a normal mask. On the firewall, the 1 indicates a match. So it would be your normal mask. So this is the network that I want to block. The mask would be 255.255.255.0. So that's a big difference if you're used to writing the ACL on a router. The way you write an ACL on a firewall is using the normal mask. Okay? So something to keep in mind. So to recap, what are the differences between the router ACL and a firewall ACL? Let's write them down for you guys. Although they're all over here, but let me just write it for you. Router ACL versus firewall ACL. I'm going to write the characteristics of the firewall ACL. Number 1, it's a named ACL, not a numbered ACL of 1, to 99 is standard, 100 to 199 is extended, and so on. It's a named ACL, it's an extended ACL, not a standard ACL. If you just want to block the source, you put the source and the destination as any. It only affects through traffic, whereas a router ACL will affect the through as well as the to traffic. The next thing is a mask. It uses a normal mask, not an extended mask. These are the four major differences between not a wildcard mask or an inverse mask. Major differences between an ASA ACL versus a router ACL. These four bullet items that I listed for you guys over here. All right, now the syntax for it. Access-list, that's the name, that's the command. The name, whatever you want to call it, it's up to you. Okay. The action, which is either going to be a permit or a deny, just like on a normal ACL. So the only difference, so you see that over here, is it uses a name as the identifier of the ACL, not a number. Then the rest of it is pretty much the same, like protocol. You put the protocol over here, which is either TCP, UDP, ICMP. These are some examples of that. Source IP, destination IP. The difference over here is the mask. If you're doing a network mask, what would you need to put in? So let's say as I showed you an example, let's say I was doing 195.110. My mask over here, I would write it as 255.255.255.0, not as 000.255. That's the main difference. And then the end, you would put the port number and or the type. So let's do two ACLs as an example over here, so you guys have a gist of it. Although they're coming up as well in the next slide. Access-list. Let's say I'm applying it to the outside interface, so I'll use the word outside. Permit, I'm allowing traffic from outside. TCP traffic, any source to, let's say, this network, 192.168.1.0. Continuing on, my mask, which is a normal mask, not the inverse mask. EQ, let's say 80. So that's the port that I use, just like a normal ACL. And if it was ICMP, I would say access-list. Let's say I want to allow echo reply coming back in, because ICMP is not inspected by default, so I can say permit ICMP is your protocol, any echo reply. So I'm allowing the packet type as echo reply coming back in. Same concept that you had on a router ACL with the subtle differences that I talked about in terms of the firewall ACL. Now, how do I apply it? On the router, you would apply it by going under the interface. You would say interface, let's say E0/0. The command would be IP access dash group and the name or number in or out. This is on a router. On the firewall, the command is still the same. It's still called the access group command. ACL name would match the name over here. The direction, you will need to specify in or out. So I'm applying this ACL in the inbound direction on what interface? The word interface followed by the interface name. Outside, inside. Generally, you would apply an ACL to the outside interface. So a typical example of what I did over here, I called my ACL outside. So the way I would apply it, it's a global config command, access-group, the name of the ACL, which I called outside, just so that I know what it's applied to, the direction, which is going to be in, the word inside, the word interface, and then the interface that I want to apply it on. Because let's say I want to apply it on the outside interface, I would say outside. This is the interface name, this is the ACL name, and this is the direction that you're applying it. So that's what I have over here. ACL name, direction, in or out, and interface, the word interface, and then the interface name, which is inside, outside, whatever you used. All right, that's how the commands are configured. Some examples over here. Route ACL, just as a comparison, if I wanted to permit the 190 TCP from 192.20.0.0.0.255, the inverse mask to any destination for telnet EQ23, that's how I would do it. Access-list 101, permit ICMP, any source trying to do what? A ping to this network, echo is a ping packet. And then I would take this 101, which is an extended ACL, and apply it to the interface by going inside the interface, IP access-group 101, the name and the direction, inbound into E0/0. Now on a firewall, the same thing will be accomplished using a little different in terms of the syntax. The concept remains the same. Access-list, this is a name. I could have used a number, but it would still use it as an alphanumeric. It would still use it as a name. Permit TCP, the protocol. Notice the mask has changed from a 000.255 to 255.255.255.0. Any and EQ23, the port number. That remains the same. Outside permit ICMP, again, the mask changes. The rest of it remains the same. So that's how you create the ACL. How do I apply it? The way I apply the ACL, access-group, again, just like I explained a bit ago in the previous slide, access-group, the name, that's the name of the interface, the direction, the word interface, and the name of the interface. I'm applying it to the outside interface. All right, that's how you do it on a firewall versus a router. An example of the two. Now let's go ahead and implement that in a lab environment. My lab configuration builds on the previous lab. That was the BGP lab that had all the routing configured. So in this particular lab, what I'm going to do is, the previous BGP lab is what I'm basing it on. Allow the following traffic through the firewall. The host R2 192.1.20.2 should be able to telnet, SSH, and ping into 10.11.11.0 network. So how would I do that? How do I write this ACL? Let's go ahead and do it. Over here, let me open up my notepad, and I'll put it over here so we can do it, and then I can paste it onto your device. So the first requirement over here, I want to create an ACL to allow traffic from 192.1.20. 192.1.20 is this IP address. So the traffic is going to be coming in from outside, and they were allowing to the inside interface, I believe. So to the 10.11 network for telnet, SSH, and ping, but only one device. That's this guy. So but there are three different port numbers over here. So I'll give it a name. I'll call it outside as the name of the ACL. Permit telnet, SSH, and ping to 10.11.11.0. So permit telnet, which is TCP based host 192.20.2 to the network 10.11.11.0. The mask is the normal mask, and then EQ for telnet, and another access-list outside permit. I missed something. AT TCP host, same destination, EQ22. That takes care of my second requirement. And ping, the third one, is echo, which is ICMP based, access-list outside permit ICMP host 192.1.20.2 to 10.11.11.0, the same network, but for the packet type echo, which is the packet for ICMP. That's the first thing. The next thing they want to do is the 199.110 network should be able to access R3, whose IP address is 192.168.3.3 for telnet and ICMP. So in this case, access-list, same ACL, permit TCP 199.110 network, so the mask, host 192.168.3.3 EQ telnet and ICMP. So again, permit TCP 199.110 to host, same host, echo. Sorry, this should be ICMP for echo. Let's check. Allow telnet and ICMP for this particular host. R3 and R4 should have full access to each other without using any ACL. R3 and R4, if you guys remember, we have set the security levels over here to 50. So if I want them to talk to each other, what they're referring to, what the question is asking you to do, is to use that same security traffic interface command. Permit inter interface. Maybe they belong to the same department. How do I apply this ACL? Access dash group outside permit, access dash group outside in interface, the name of the outside interface, which is outside. Let's do a before and after though. Let's go ahead and try to see if I can ping from R2 to let's say 10.11.11.0 network, which is, I want to try to ping 10.11.11.1, which is IP of router 1. So I'll go to router 2, show IP route. I should have a route towards this particular network, 10.11.11.0, and R1 should have a route to the 20 network. If it doesn't, it's not going to work. So it doesn't, so I'll put a route in there. IP route for the 20 network through the 10.11.11.10 IP. So this guy over here, 20.network from the 10.11. So now let's go to router 2 and try to ping it. Ping 10.11.11.1, which is router 1. It's not going to work. It's going from the low interface to the high interface. Or for that matter, let's try to do a telnet and see if that works. Both of those guys will fail because it is not supposed to work. Besides that, we'll try to do the 199 network towards R3. R3, let's see if it has 199 as a host, and R3, I want to make sure R2, which has the show IP interface brief, should have 199 as loopback 199. Show IP route, I want to check the routing. It does have through BGP learn 3 network, and on R3, does it know about the 20 network? I don't think it does, because 20 I didn't advertise in any of the routing protocols, so I'll put a route over there for the 20 network. 20.0 192.168.3.10. So that's also there. Now let's try to do the ping and the telnet from the 199 network towards 3.3. So how do I do it? Over here, my what do you call it? 199 network is loopback 199. So what I'll do over here is I'll do a ping 192.168.3.3, the destination with a source of 199.111. Doesn't work. I'll break the ping. I know it's not going to work. 3 pings is good enough. Or I try to do a telnet to it. Again, it should not work. Source interface loopback 199. It's not going to work because the ACL is not there. At the same time, the last thing that they also wanted to do over here was this. R3 and R4 should have access to each other without using an ACL. Right now, if I go to the ASA firewall, and you can do a show name if you guys remember from the previous labs, I put the DMZ 3 and 4 with the same security level. So on R3, if I try to ping 192.168.4.4, it's not going to work. Or on R4, ping 192.168.3.3, it's not going to work. Why? Same security level. So all these things are taken care of by the listings in the ACL, applying the ACL to the outside interface, allowing out to inside or out to DMZ traffic, and same security traffic for that R3 to R4 traffic. So let's see if it works. I'll go over here, go to the ASA firewall, global config, and paste it. So permit TCP host 20.2 should be able to go into do a show run access dash list to see the content. So I'm allowing 20.2 host to go to the 10.11.11 network for telnet, SSH, and echo. I'm also allowing the 199.110 network to come into 3 for telnet and echo. I've done that. I have applied the ACL. We can check that by doing show run access dash group. It's applied to the outside interface. we can run the shows run same security interface, which is permitting the traffic. So the three things that we talked about, four things that we did prior to the ACL should now start working. So I'll go to router 2 now. This was not working. This is now working. Why? Because of that ACL entry. I could not ping 10.11.11.1. That is working. I could not ping 3.3. That should be working, unless I did not apply it or allow it. There's something wrong with that. Oh yeah, I need to use a proper source. The one that I'm allowing is 199. That's working as well. Let's do a telnet to 10.11.11.1. So all the different things that we tried that were not working before, after applying the ACL, they started working. Now R3 to R4, remember this, same security traffic. I've not applied any ACL, but because of the same security traffic command, now they will be able to talk to each other. I haven't put any ACL over there. They're still talking to each other, which was not happening prior to that. All right, all the commands that are required are over here. ASA outside ACL, the traffic that was allowed, I put that in Notepad before I pasted it, and this is where I applied it. ASA to DMZ, same security traffic, did that, verify the ping. I did a before and after so you could see what the ACL's effect was to do it. So all the different requirements are met. So that's how you write an ACL, a very important component of your ASA firewall. Hopefully you have a better understanding of the ACL. I'll see you guys in the next video now.